Alright, today we're going to continue to talk about factoring trinomials. And this is one of the last sections that I usually do because I do not want you to think that the majority of problems are like this. But we're going to continue to factor just like we've learned the last few days, trinomials, ax squared plus bx plus c. Not every thing that I give you, not every equation, not every trinomial is going to be able to be factored. If there comes a point where you are listing all of your factors and looking for their sums or their differences and you cannot find anything that adds or subtracts to give you your middle term, then that is considered a prime polynomial, and you can write the word prime. The majority of the things I give you are not like this, but there are ones that are not going to be able to be factored. You could write prime or you can write unfactorable. Either way works. That doesn't mean that there isn't a parabola, because we've talked a lot about how the things that we are finding, when we factor them and we solve and we find the roots or the zeros or the x-intercepts, we are looking for where the parabola crosses the x-axis. Not all parabolas have to cross the x-axis. If this is your grid, think about a parabola that might come in, might start here and go up. There is a parabola and it exists, but the lowest point on that parabola is this vertex down here, and that doesn't have a place where it's going to cross the x-axis, because the lowest point is above the x-axis and the entire graph goes up from there. Likewise, you could have one that starts down here and goes down. Again, the highest point on this one is below the x-axis and the rest of the graph goes down from there. So a prime polynomial does not mean that there isn't a parabola. There will be a parabola if there is a quadratic equation. There will be a parabola. It just doesn't cross the x-axis. So if you look at this, we have a trinomial that has a number in front of the x squared, so we learned that we need to multiply the first number and the last number together, which gives us 4. So we are looking for something that multiplies to give us 4, and in this case subtracts to give us 5. Well, the only factors of 4 are 2 and 2 and 1 and 4. We are subtracting because the last term is negative. 2 minus 2 gives me 0. 1 minus 4 or 4 minus 1, it doesn't matter. Their difference is 3. Neither of those pairs of factors gave me a minus 5 when I was done. Because I have listed all of the factors, and you're going to have to do the same thing. If you believe that something is prime, that is okay, but you need to list all of the factors in a chart. I know before I've said you don't have to make a chart if you know the answer, and that's true if you know the answer and it has an answer. But if you are trying to tell me that it does not have any factors and it's not going to be able to be factored, I want you to prove it to me by listing all the factors of the number and all of the sums or differences in order to prove to me that I listed all the factors and none of these were equal to 5. Only now that I've written out my chart and I've proven that I can't find anything, I can write prime. I do not want you just defaulting to thinking things are prime because you can't think of one of the factors off the top of your head. If you think it might be prime, then start listing the factors and list them all to prove to me that it is prime. This one, again, is a trinomial with a number in front of the squared, so 8 times 9 gives me 72. So I need factors of 72, and I'm looking for factors of 72 that add to give me 19. Now 72 is kind of a pain in the butt. 72 has a lot of factors. So I'm just going to list them for you. So we have 1 and 72. We have 8 and 9. We have 2 and 36. We have 6 and 12. We have 4 and 18. And we have 3 and 24. A lot of factors. okay? When you add these up, you get 73, 17, 38, 18, 22, and 27. We're adding the factors together because our last term is positive. I have listed all of the factors of 72, and I've found all of those factors' sums. None of these factors give me what I'm looking for. I'm looking for them to add up to give me 19. None of those work. I have written out all the factors and all of their sums, so now and only now I can write that this is prime. You cannot just assume that something is prime without writing out all the factors and all their sums or differences. This one, you should notice first off that it has an equal sign. So before you do anything, you need to make sure that it is set equal to 0. So I'm going to subtract the 4 and add the 3a, and I'm just going to do it all together. You can do it separately if you'd like, but everything has to be moved to the other side. That gives me 8a squared minus 6a minus 9 equals 0. Now that I have that, I can see that I have a trinomial with a number in front of the square term, so I have to multiply my first and my last. And again, I have 72. But this time I'm looking for factors of 72 that subtract to give me 6. Since I already found all the factors of 72 on the previous slide, I'm just going to go off of that. And I know that the factors of 12 and 6 give me 6. So this is not prime. This is something that I'm going to be able to factor. So 12 and 6, when we have this 5-step factoring, you have to rewrite this problem splitting up that middle term. So we have 8a squared. I'm splitting this into now 12a and 6a, then minus 9 equals 0. Now and only now I put my signs in. This tells me that my signs are different. This tells me what the biggest number goes with. So the 12 is the negative and the 6 is the positive. Now that I have that, I can factor by grouping. So I group these first two. I can take a 4 and an a, which leaves me with 2a minus 3. Here I can take out a positive 3, but no variables, which leaves me again with 2a minus 3, which is what I want. When I go to write my answer, I write whatever was in the parentheses once, so 2a minus 3, and the leftovers in the other, 4a plus 3. I am not done with this because I still have to solve it because there was an equal sign to begin with, so it has to be solved because of that equal sign. So remember, I take each factor individually, each grouping, and set it equal to 0. So 2a minus 3 equals 0. Add the 3, so 2a equals 3. Divide by 2, so a equals 3 over 2. Leave it as a fraction if it doesn't come out evenly. Then the other one, I have to take the 4a plus 3. I'm going to go up here because I'm running out of room. 4a plus 3 equals 0. Subtract the 3, which gives me negative 3. Divide by 4, so a equals a negative 3/4. Those are my answers. Those are my roots, my solutions, my x-intercepts, my zeros, all the same thing. But since there was an equal sign, I had to make sure everything was on the same side, equal to 0, factored it, split it up, and then solved each factor individually. This one again has an equal sign, and it is not set equal to 0 yet, so I have to start by subtracting the 20, which gives me 6n squared plus 7n minus 20 equals 0. 6 times 20 is 120. Looking for factors of 120 that subtract to give me 7. Again, this is a time-consuming one, so we'll just jump to it. If you were on your own, you would go ahead and figure out all the factors of 120 until you found ones that subtract to give you 7. But the ones that are going to work here are going to be 15 and 8. So 15 and 8 are what we're going to use to split up that middle term. So we have 6n squared. We have a 15n and an 8n, and then minus 20 equals 0. Now I put my signs in. This tells me my signs are going to be different. This tells me what the biggest number goes with. So my biggest number was 15, so that gets the addition sign, and then the 8 gets the subtraction. Now that I have it split up, I can factor by grouping. So 6 and 15 are both divisible by 3, and I can take out an n, which leaves me with 2n plus 5. If I look at my next two terms, they're both negative, and I would like my final inside my parentheses to both be positive, so I'm going to take out a negative 4. Negative 8 divided by negative 4 is a positive 2n. Negative 20 divided by negative 4 is a positive 5. So again, by taking out that negative, I changed the signs, which I wanted to be able to do to make them match. Because now I have 2n plus 5 as one of my factors, and then the leftovers from the outside, 3n minus 4, as my other set of factors. Again, I'm not done because it's set equal to 0, so I have to solve. So 2n plus 5 equals 0, gives me negative 5 over 2. And then the last one is going to be 3n minus 4 equals 0, which gives me n is a positive 4/3. And that's it for that. This last slide is just a review of all the stuff that we've done so far. I'm not going to do the first one because we just did a couple like that where you had a trinomial with a number in front of the squared term. Remember, multiply the first term and the last term, split up your middle term, and factor by grouping. The second one is fairly simple because there's no number in front of it, so that's automatically you write your two sets of parentheses with your x's in the front. What multiplies to give you 10 and adds to give you 7 is going to be 5 and 2. Signs are the same. This tells you they're both addition. This last one again is like what we just did. Make sure you get it set equal to 0 first. So you have a 9x squared plus 21x plus 10 equals 0, and then you're going to factor by grouping. The only thing that was new today was the fact that there are prime polynomials. There can be unfactorable trinomials that are given to you. But the rest of it is review. You just factor it out. If there is an equal sign, you make sure it's set equal to 0. Factor it and then solve for each of the pieces just like we've done in the past. Your assignment is only 5 problems, 23, 35, 37, 38, and 40 on the same page as the other day, so 499B. So go ahead and work on that and then turn it in when you're done.